everyone, my name is Jin Cho, founder of Soelect. I welcome you here today and look forward to telling you about this amazing company. Soelect, founded in December 2018, is a rapidly growing battery tech startup company located right here in Greensboro, North Carolina. We are developing next-generation battery components, which are lithium metal anode and its compatible polymer and liquid electrolyte systems. We understand and redesign lithium metal anode rather than lithium metal foil for rechargeable secondary battery application. Are you ready to dive into what we are doing here? Please follow me. As many of industry experts agree, lithium metal anode is recognized as being the ultimate anode material due to its large energy density and structural simplicity. However, it is not easy to fully utilize its potential in a secondary battery application due to some technical challenges, one of these challenges being lithium metal dendrite. However, we believe that Lithium X can mitigate the issue very effectively, even under quick charge conditions. Currently, we are in the process of scaling up this technology to a fully automated ultra pilot scale. Now, let me introduce Dr. Robin Walton. She's our Director of Operations, and we'll walk you through the facility and manufacturing plan.
Thank you, Jen. And I'm very excited to share with you our current status and upcoming plans for our facility. As of right now, we are occupying 15,000 square feet of space. Our 2,800 foot square dry room is where we produce our prototype product, Lithium X anode, and conduct electrolyte research. Our custom dry room was designed by local vendors who did not have previous experience. We now have a local partner ready to jump in and assist us. I think this is a perfect segue to talk about challenges. While North Carolina is well known for manufacturing, having a business-friendly climate, and for its first-class research universities, there's an insufficient number of workers with the necessary skills to support a battery ecosystem in North Carolina. As we develop our pilot line facility, we are also challenged in the way that there are few domestic suppliers across the board of the value chain. Relying on overseas vendors can prove to be very challenging due to cultural and language barriers, higher and hidden costs, shipping risk, long lead times, and unexpected delays.
As Robin said, we are facing various challenges in our business. Now that we are looking to further expand, and governmental assistance is essential to support emerging market demand. We are ready to build a team to fortify the domestic supply chain in the U.S. Let's come and work together for manufacturing success of the U.S.
Hi, my name is Emery Brown, and I'm a manager here at Amphenol, and I'm here today to present you as to why we believe solid-state electrolyte materials are critical to the supply chain for electric vehicles. Enhanced energy density and safety are the driving force behind next generation all solid-state battery technologies. And the solid-state electrolytes are the core technology of these advanced batteries, serving as a separator and the ionic conducting material in the cathode and in some composite anode designs. Many of the major automotive OEMs have announced roadmaps for solid-state batteries in 2025 and 2035. And by 2025, it's projected that several hundred tons of solid-state electrolyte materials will need to be manufactured to meet this growing supply chain demands in the United States. However, this brings us to the question, where is it coming from? Most automotive OEMs plan to be all EV, all solid state by 2035, with numerous factories spread throughout the United States. However, only 2 companies in the U.S. have so far have advanced scale production of solid state electrolyte materials, Amphenol and Soelect Power. And it should be noted that the other companies in the market are either not truly all solid state or polymer based, or have not announced the scaled solid state like production to meet the growing supply chain demands. Amphenol is pioneering the scaled solid state electrolyte manufacturing with over 200 repeating customers globally and 1 million in annual revenue. Amphenol has also fulfilled well over 1,000 orders of various sizes. And it should also be noted that Amphenol is the only US-based material company to make our products commercially available while advancing scale production to meet the growing supply chain demands. Amphenol has over 20 patent-related applications, with 4 DOE grants awarded with several more pending. Amphenol is also in collaboration with multiple universities and national labs and is also currently partnering with several automotive OEMs to meet their solid-state electrolyte. Ampsera's R&D facility is located in Tucson, Arizona, where the dry desert is great for dry room operation, as it will lower costs and hopefully enables scale production solid-state electrolytes at a low cost. And Arizona is also a growing hub for high-tech component development thanks to the dry desert. Ampsera also promotes a diverse workforce, and we project over the next 10 years, the scaled solid-state electrolyte manufacturing will create over 2,000 jobs, ranging from high school level technicians to PhD researchers. This would also be very beneficial to our local Native Indian nations and other minority groups. The scaled solid-state electrolyte manufacturing will expand the battery ecosystem in the American Southwest, bringing EV manufacturing and spent EV battery recycling to Arizona, creating more jobs, as well as promoting EV adoption. For more information, please contact us at www.ampsera.com or directly at info@ampsera.com.
Hello, my name is Jay Carroll. I'm the Regional President of Arkema Inc.'s High Performance Polymers business. On behalf of Arkema Inc., an innovative manufacturer of sustainable materials, we greatly appreciate the opportunity to provide this short video and hope that it is useful to the Department of Energy as it finalizes the upcoming battery materials manufacturing funding opportunity. We hope that we'll be able to participate in this opportunity, one that we believe is right in line with our background and experience. As a longtime supporter of the Paris Climate Agreement, we strongly support the efforts of the Biden administration, Congress, and many others to advance electric vehicles and their key supply chains in the U.S. We believe these efforts and other related actions will help reduce greenhouse gas emissions and help the world move to a more sustainable future, while also securing jobs and an American manufacturing base. Thanks again for this opportunity to share some of our thoughts on this important topic of battery materials manufacturing.
Arkema Inc. is a domestic manufacturer of PVDF, an essential material for battery binders and separator coatings. Lithium-ion batteries cannot effectively function without PVDF. The safety and performance of lithium-ion batteries depends greatly on the quality of the binder, as well as the quality of the protective coating on its separator, and PVDF is critical for both. As this map shows, there are significant and growing investments in U.S. battery manufacturing, but too much of this key industrial sector remains reliant on binder and separator coating materials that are produced overseas. The Wall Street Journal, supported by Morgan Stanley Research, recently reported that although global battery-grade PVDF capacity will more than double between 2021 and 2025, demand will quadruple in the same time. Therefore, to meet this enormous demand growth and to protect U.S. interests and ensure these materials are produced in a robust way in the U.S., we strongly support the eligibility of PVDF under Area of Interest 10, the Commercial Scale Domestic Battery Component Manufacturing Open Topic, as this will help support the necessary capital investments. Any project under this program will require proper coordination of regulatory requirements at the federal, state, and local levels. The recent supply chain uncertainties also underscore the importance of having the entire supply chain for key end-use products like advanced batteries be based in the U.S. As a manufacturer in the U.S., Arkema Inc. understands the workforce requirements that will be needed, and we have sought the support of a key state local economic development agency to help support workforce needs as well as environmental justice goals. In addition, university and public-private R&D assistance can help support the capital investments. In step with Arkema Inc.'s commitment to helping build a sustainable world, our EV battery and separator coating materials are produced without the use of fluorosurfactant processing aids, and we believe this is an important feature in terms of creating more sustainable modes of transportation. Arkema is also working with the DOE's Advanced Manufacturing Office to help develop the next generation of PVDF binders and separator coatings that will be manufactured in a cost-effective and sustainable way. Thank you for the opportunity to explain how our materials contribute to a strong U.S. supply of sustainable materials that are essential to building a sustainable future.
Hi everyone, my name is Vahid Sarajian from Edge Global Innovation, and we have developed a new generation of liquid electrolytes to solve their major drawbacks. The result is a new product that doesn't catch fire. It works under extreme thermal and physical conditions. It doesn't emit gas, and it's shock absorbent. We are currently running different tests on the samples, and we expect to finish the tests by the end of Q2 of this year. But so far, we're very pleased with the results. Our plan is to establish the manufacturing plant in Orange County of Texas. Orange County is an opportunity zone with low-income community in Texas, but it's strategically close to major industrial zones of Texas, like Greater Houston area, and at the same time to Galveston as an export hub. So we're counting on Orange County of Texas. From a workforce skill requirement standpoint and complexity of the manufacturing process, they're both reasonably low. So we expect to be able to hire people from low-income community, train and educate them without major concern. So the overall, the process is very straightforward. Our product is technologically very advanced, cost competitive, and it has some major advantages from technical and safety standpoints. And at the same time, it creates some stable and permanent jobs here in the US and in low-income communities. Thank you very much for your attention. Again, my name is Vahid Sarajian from Edge Global Innovation. For more information, please contact me at 979-229-5563 or email me at info@egigroups.com. Thanks.
Koura is a global leader in the development, manufacture, and supply of fluoroproducts headquartered in Boston, Massachusetts. Koura owns and operates the world's largest high-purity fluorospar mine in Mexico. We process this fluorospar at the world's largest hydrogen fluoride plant on the US-Mexican border, some of which feeds our specialty fluoroproducts plant in Louisiana. Fluorine is a critical element in the battery supply chain and is used in the production of battery salts, additives, and binders. Koura is actively developing fluorine-containing battery materials, leveraging its vertically integrated supply base. The supply chain for electrolyte salts is currently based in Asia. Lithium hexafluorophosphate is the electrolyte salt used in nearly all lithium-ion batteries. Chinese production of LiPF6 currently accounts for over 90% of the world's supply. As a result, LiPF6 represents a single point of vulnerability for the manufacturing of lithium-ion batteries in the United States. Koura is working on establishing a North American-based supply chain for LiPF6. The first phase would be to establish a North American LiPF6 production facility with a capacity in the range of 5,000 to 10,000 metric tons, which could serve up to 30% of the US demand by 2025. We plan to continue capacity expansions as the domestic market grows. Koura has the in-house engineering and technical resources, as well as strategic partnerships to ensure the development and implementation of best-in-class LiPF6 process technology. Koura will provide HF to its LiPF6 production facility from our North American mine. We will also actively seek to use lithium feedstock from recycled battery materials obtained from North American recycling sources. A critical aspect of LiPF6 production is the production and handling of HF. Koura has an established fluorochemical facility and team at each of our plants in North America, which has the experience producing and handling HF at scale. The addition of LiPF6 manufacturing to our existing production facilities, including the related permitting, site development, and process development, will be handled by a management team and employees with significant experience in safe manufacturing of fluoroproducts. Koura also has established procedures for training new workers as the LiPF6 manufacturing plant is brought online. Finally, Koura has a formal community engagement management process to involve communities and stakeholders.
Hello, my name is Mary Whitmoyer, XEV Venture Lead at the Chemours Company, and I'm pleased to share about Chemours and our work to advance electric vehicle battery technology. The Chemours Company, headquartered in Wilmington, Delaware, is a leading global provider of performance chemicals. We have over 6,500 employees spanning 58 locations that include both manufacturing units and R&D centers. And while our global footprint allows us to serve thousands of customers across 120 countries, the bulk of our operations are located here in the United States. Sustainability is at the heart of everything we do at Chemours. In 2018, we announced 10 aggressive goals to bring responsible chemistry to life by 2030. The goals are divided into 3 pillars and act as our guiding light as we invest in long-term growth opportunities that will drive to a more sustainable future. Our product portfolio and recognizable brands provide critical raw materials for diverse market segments. And our capabilities include a deep understanding of fundamental chemistry and an ability to tailor products for optimal performance. We are a leader in developing solutions that propel society forward, and this includes investment in electric vehicle battery competence and new products to support this space. Today's market is placing many demands on electric vehicle battery performance, manufacturing, and cost. And we at Chemours have solutions to enable the industry to solve many of these challenges. Our Teflon fluoropolymers, including PTFE and electrode binders, have the electrochemical stability to enable high voltage cathodes, while also allowing for the use of a solvent-free electrode manufacturing process that reduces both environmental footprint and cost. Chemours also has a supply of alternative carbon material as a potential precursor to battery-grade graphite anode active material. Chemours' manufacturing of our battery solutions is anchored right here in the United States. We produce Teflon fluoropolymers in our Washington Works operation in Parkersburg, West Virginia. And strong electric vehicle growth and expected adoption of the solvent-free technology will result in a growing need for our Chemours products at this site. At our mineral sands mining operation in Stark, Florida, we have vast reserves of our alternative carbon material. And in addition to our manufacturing facilities, Chemours has a new research facility, the Chemours Discovery Hub, designed for collaboration between Chemours, our customers, and the scientific and academic community, including our neighbor, the University of Delaware. I thank you for listening, and I encourage you to reach out to our team for any questions or collaboration.
Amphenol Corporation, headquartered in Wallingford, Connecticut, is one of the world's largest manufacturers of high-technology interconnect, sensor, and antenna solutions. Amphenol Sensors, a division of Amphenol, is a leader in innovative sensor technologies and forward-thinking measurement solutions across all major market segments. The Amphenol Sensors team has a history of working with the U.S. Department of Energy through the ARPA-E program and is excited to have the opportunity to submit a proposal for Area of Interest 10, commercial-scale domestic battery component manufacturing open topic. Our sensing solutions monitor battery health, battery connectivity, and early warning of thermal runaway. Battery failures can result in an internal reaction that generates heat and chemical decomposition of the battery cell, which is known as thermal runaway. Our battery cell connection systems have built-in temperature sensors to monitor battery health and efficiency. Our Red TR product, which provides early detection of thermal runaway, uses 2 primary sensors, a hydrogen gas sensor and a specialized pressure sensor. Our challenge is to grow faster and become a true global market leader in battery management and safety. To achieve this and keep up with market demands, we need significant investment in production capabilities, new technologies, as well as localizing our complex supply chain. To remain competitive and rely less on overseas contract manufacturers, we would expand our production and engineering capabilities in 3 separate sites. The first is our facility in St. Mary's, Pennsylvania. Our St. Mary's community is ready to embrace fresh investment in manufacturing, which will bring new jobs to the area. The St. Mary's region leads the world in powdered metal products for the automotive industry, and will be hard hit by the move away from internal combustion engine vehicles. At St. Mary's, we would invest in a production line for flexible circuits, injection molding, and production lines for our cell connectivity systems. For our red TR early detection of thermal runaway sensors, we look to add the capability for hydrogen sensor element production, as well as surface mount electronic production lines. These operations are currently performed overseas. The next facility is in Fremont, California, where we have an existing MEMS fabrication plant. With additional funding, we would add capacity to move our pressure die manufacturing from Asia to Fremont. This will support the production of the red TR sensor in St. Mary's, Pennsylvania. The third facility is in Mesa, Arizona, where we would further support the pressure sensor production by localizing operations such as die attachment, wire bond, precision gel and adhesive, precision overmold, and high-volume calibration in Mesa. Amphenol Sensors is determined to consolidate and defend its market position in the battery safety and monitoring application space. We would ask for funding to localize our operations quickly, improve our competitiveness, and become less reliant on overseas contractors. We have a track record of success and the skills to execute our plans efficiently. Thank you.
With more than a century of expertise, Stryten Energy is a leading manufacturer of energy storage solutions. Stryten has more than 2,500 employees that span across its 10 plants and 2 million square feet of manufacturing space located in the United States. Stryten provides high-quality lead, lithium, and vanadium redox flow battery solutions, as well as intelligent chargers and energy performance management software that power everything from submarines to subcompacts, microgrids, warehouses and distribution centers, cars and trucks, trains, telecom networks, and data centers. Stryten Energy stands ready to support the increasing need for economical, reliable battery solutions and to grow at the speed needed to meet the expected domestic demand in the future. Our clear strategic goal is to design, manufacture, and service the next generation of lithium products made in America, utilizing our groundbreaking, safe, and reliable lithium-ion energy storage technology originally developed for military applications. To meet the growing business and consumer needs for energy storage, we are working to commercialize and build manufacturing capabilities in the U.S. for our i6T lithium batteries, as well as modular and scalable lithium energy systems. Progress to date is exciting as we incorporate the best-in-class performance of the latest lithium chemistry, newest electronics, and modular scalable mechanical design with process automation in mind. To enable the U.S. to compete with China and other offshore providers, we need to fully utilize the very latest highly effective automation equipment technology in all our lithium production. State-of-the-art automation will enable U.S. manufacturers to achieve competitive lithium product cost and the necessary capacity to satisfy the rapidly expanding U.S. market demand, while also preserving U.S. jobs and transitioning to a high-tech manufacturing workforce. Stryten Energy proposes the DOE consider funding some of the top lead battery manufacturers in North America to accelerate the transition to advanced lithium manufacturing and significantly expand the breadth and capacity of a U.S.-based supply chain of modern energy storage products for the consumer, industrial, and military markets. This funding scope would include engineering development of lithium drop-in packs with highly automated manufacturing equipment and retraining our U.S. workforce. Funding should be prioritized for U.S. companies with an established manufacturing domestic footprint and a demonstrated ability to produce batteries at scale. Stryten Energy also suggests that funding is directed to companies with the manufacturing expertise and the financial backing to successfully bring new lithium pack production to market. For more information about Stryten Energy and our commitment to the clean energy transition through our end-to-end energy storage solutions, visit our website at stryten.com or contact us at stryten.info@stryten.com.
Just as we saw electric cars go from concept to reality over the last decade, we're right now witnessing the dawn of the age of electric aviation. To understand how big a deal this is, we need to look back at the birth of the jet age in the 1950s. Back then, who would have imagined that jet travel would connect all the corners of the world? Trips that had previously taken a week could suddenly be completed in the time it takes to watch a few movies. Over the last century, U.S. leadership in aerospace has been critical to its continued economic success. And as we speak, the aerospace industry is engaged in the next technological race based on the electrification of aviation. One subsegment of electric aviation, known as advanced air mobility, has been projected to create 280,000 jobs and add $115 billion annually to the U.S. economy by 2035. Aviation is one of the most difficult sectors to decarbonize, and electric aviation provides a zero-emissions path to doing that. At Joby Aviation, we've been flying full-size, all-electric aircraft since 2017, with over 1,000 flight tests, including flights of over 150 miles on a single charge. We've been working closely with NASA and the DoD as we develop these capabilities, and we're working with the FAA to certify these aircraft for commercial operations in just the next few years. We design and manufacture aircraft, batteries, motors, and other components on the California coast. And as we transition from development into production, we're taking these challenges and scaling our capabilities for mass production. At Joby, we are highly vertically integrated. We design, build, and test our own batteries, achieving higher energy densities, longer life cycles, and faster charging. We've created aviation-grade electric motors with class-leading torque and power. We're looking to partner with the Department of Energy to fund domestic manufacturing of key components of electric aviation right here in the USA. At Joby, we're ready to lead the way in this critical new industry, and the government support can assure the U.S. remains a global leader in zero-emissions electric aviation.
Hello, I'm Mil Ovan, Chief Marketing Officer of Navitas Systems. The mission of Navitas Systems is to make tough batteries for demanding applications in both defense and industrial applications. We figured if we could make a battery tough enough to survive the rigors of a tank, we can make a lithium battery tough enough for the largest commercial battery market outside of car batteries, which is the forklift battery market. And we make advanced batteries for every battle domain, from under sea to vehicles to soldiers to aircraft and all the way into space. As you can see from some of the product pictures, we can't show you most of them, however, given confidentiality. They come in a variety of shapes, sizes, voltages, and chemistries, which are optimized for each demanding application. For approaching 10 years, we've been fortunate enough to have been awarded contracts by both the Department of Energy as well as other service branches like the DoD, NASA, and DOT. We are researching advanced and beyond lithium battery chemistries like silicon anode and lithium sulfur. We're also developing manufacturing technologies in such areas as dry process electrodes to reduce the use of VOCs in making electrodes currently, as well as techniques to dramatically reduce the current drying time of electrodes. In conclusion, we applaud the DOE for its recent notice of intent to provide grants for advanced battery manufacturing. One issue for us, though, as a mid-sized battery company, is that the bar seems to be set very high for minimum grants and associated cost share sizes of $50 million to $100 million. This will keep companies like ours from getting the needed funding to grow our company. And as well known, the majority of innovation and job growth come from small companies, and we therefore believe that adjustments should be considered by the DOE regarding these minimum grants and cost share amounts. We are shovel ready. We just have a smaller shovel, but we can work fast and we can work smart. We laud the Federal Consortium for Advanced Batteries for being formed, as many U.S. agencies, chief among them the DoD and the DOE, have a vital stake in supporting the growth of the advanced battery supply chain in the U.S. As you can see from our presentation, we serve both commercial and government military markets. We therefore believe that funding decisions from the DOE should also consider applicability to the DoD, thus fulfilling the aspirations of FCAB to leverage mutual DoD and DOE investments in advanced battery companies. And finally, we believe that commercial markets like the forklift market, which is, as I mentioned, the largest battery market outside of car batteries, should be acknowledged for funding and not strictly considering just automotive and grid battery markets. So I want to thank you very much for your time and attention and appreciate all that you do.
Hello, this is Chris Turner, the CTO for Inventus Power. I'm going to talk about today our area of interest, which is battery pack manufacturing. Inventus Power is the largest independent lithium-ion battery pack manufacturer in the United States. Our headquarters is just outside of Chicago in Woodridge, Illinois. We design and manufacture batteries for a wide range of products and markets that I'll discuss later. Inventus Power develops and manufactures battery packs for a wide range of applications. We service everything from consumer to medical, military, and now larger applications in light electric vehicle up to hundreds of volts and 100 kilowatt hours. We are headquartered just outside of Chicago in Woodridge, Illinois, where we also have manufacturing facility for medical and military applications, as well as our U.S. Engineering Center. We have locations globally with factories located in southern China, Malaysia, Brazil, and Tijuana. We also have 2 other engineering centers, one located in Guangzhou, China, as well as Doha, Qatar. Lithium-ion has been gaining traction in a wide range of applications, some of them very critical, like our military applications, where it's being used for soldier power on up to military drones and unmanned vehicles. Lithium-ion has also become critical to the medical industry, where it's being used in everything from surgical tools to ventilators, respirators, infusion pumps, a wide range of devices that people may not realize are relying on lithium-ion either as the primary or backup source of power. As mentioned previously, though, one of the fastest growing segments of the market really is in the conversion of internal combustion engine, or ICE, and lead acid to lithium ion. This covers a wide range of vehicles, low speed electric vehicles to commercial vehicles, and you'll see some examples listed here. We have seen a severe cell market shortage since the beginning of 2021. This has really impacted a lot of applications and markets, particularly those in medical and military. It also has exposed the overdependency on relatively few key major suppliers. In summary, Inventus would like to recommend the following. We'd like to see the build out of cell and pack manufacturing capacity, not just for EV, but also EV adjacent markets. We believe there's a need for funding to be able to scale up and upgrade and automate new and existing battery pack manufacturing facilities. We'd also like to see the efficiencies that may come from being able to partner with larger automotive OEMs who already have a lot of this competency and scale. Lastly, we think any funding that's prioritized should be for partnerships and consortiums between materials, cell manufacturing, battery pack, and testing and recycling entities. We believe this really provides the best avenue to success for future growth in the U.S. Information for reference. Thank you for your attention.